to me, the core of data science is not about tools. It's not about what programming language you use. It's not about, oh, do I know the latest statistical process? It's at its fundamentals, data science is about saying, can I take, I'm trying to make a decision. How do I use data? The only qualification you need to be a real data scientist is that you use data to make decisions and you know what you're doing. And what I have found that as a practical matter, Python is definitely a majority language in the sense most places, I'd say 80% of the data science teams I know, they use Python as their main language.
Welcome everyone to our fifth Spheres of Learning talk. So Spheres of Learning is a talk show that my sphere, which is an initiative and a platform for students to build their own careers, to discover themselves, to discover what's out there, get to know about different careers from various experts. So today's talk is with Dr. Aziz Lookman. Aziz has been a friend of mine since almost 3 decades now, and
Yes.
He's a graduate of IIT Bombay and has done his PhD at Carnegie Mellon University in the US. He's also been a professor of finance and statistics at CMU. He's been at Amazon risk lending in the US, and also been an entrepreneur and run his own startup called Rational AI. He's now a data scientist at one of the leading financial services firms called 2 Sigma in New York. Aziz has been visiting India since the past few weeks, and I invited him to share his expertise and be available to many of y'all who have questions on what is this. We all have started hearing about these words called data science, and what is data science and what is it all about, and is it a fad? He's a practitioner in the field. So with that very short introduction, Aziz, why don't you tell us a little bit about your own journey and what this data science stuff is all about?
Sure. Thanks, Girish, for that very warm and generous introduction. I think the part that is absolutely correct is that I've known Girish for more than 3 decades, and it's been Girish has been a source of wisdom and joy along the way. So thanks again. It's great to sort of share with you now something on a professional platform. With that said, let me turn to my own journey. So the way I got into data science was I really got into data science before it was called data science. I got into it when it was called something a lot less sexy. It was called statistics and econometrics. So I started getting into it sometime in the mid 90s when I went back after spending some time in my career as an engineer to start getting into using things affiliated with engineering to make decisions, and that's how that was sort of my entree into it. I took some statistics courses. I found that, oh, this is pretty cool. I can actually take decisions which seem to be relatively fuzzy and come up with a quantitative basis for coming up with an answer to them. And that was, in a sense, the start of my journey. I then, when I pursued my PhD in finance, my dissertation, my research work was all very much quantitative. And from there, that gave me a pretty strong foundation from which to build, and then pick up additional techniques, particularly the more modern machine learning methods. And I've applied them over time to everything from making databases more reliable to deciding how to make loans, how to issue life insurance policies to people, to what I'm doing now, which is essentially making investment decisions. So my journey, I would say, has been more about how do you take a decision you're trying to make and figure out if you can use data to help inform that decision. So when I think about it, to me, the core of data science is not about tools. It's not about what programming language you use. It's not about, oh, do I know the latest statistical process? It's at its fundamentals, data science is about saying, I'm trying to make a decision. How do I use data and some analytical technique to help guide that decision? So I think that's, to me, really sort of the core of data science. And if you look at my own career, that's, I'm sort of living that journey. I've used data to make better decisions in fields as diverse as improving reliability of something as something as specific as databases. So somebody would call that reliability engineering. I've used it to help settle, help figure out what are damages in lawsuits. I've used it, as I mentioned, in things like finance. So when you look at it, you wonder what's the common thread, and the common thread is always this: you need to make a decision. How do you figure out whether you can inform that decision using data? So to me, that's kind of the essence of data science.
So what is the difference? You said that when you started off, it used to be called statistics. What is the difference between statistics and data science?
So let me give you two answers. Statistics is unsexy, data science is sexy. So that's the flippant answer. I think the big difference is that what has happened over time is the size of data we have has really exploded. 20 years ago, if you had a data set with even 100,000 observations, it was considered a quote unquote large data set. Now, a large data set is, even now, 1 billion observations is considered, you would call it small, but you'd at least call it a non-event as far as how do you process the data. So what has happened over time is that, in a sense, the field of data science has evolved from being the realm of statisticians to at least being the realm of statisticians as well as computer scientists. And the reason it sort of evolved that way is that as the size of the data got bigger and bigger, as a practical matter, the skills you needed to analyze the data were not pure statistical techniques. It was software engineering and computer science techniques. For example, how do you actually, if you have a data set of 1 trillion observations, how do you handle those trillion observations? Statisticians never worry about computers crashing or things like that. So what has happened is that because of this evolution of the data analysis moving from the realm of statisticians, in a sense, to computer scientists, there's also been a change in the techniques used and the purpose of those techniques. So the one big difference I think of is that statisticians or econometricians like me, which is a fancy name for economists who use data science, is we care a lot about trying to understand causality. Meaning, for example, if somebody says, what is the efficiency, what is the efficacy of, say, fertilizing a field? We'd really like to figure out, okay, you've added 1 extra ton of fertilizer. What is the impact of the extra ton of fertilizer on yield? And how do you know that is because of fertilizer, not because, say, there were better rains or because the seeds were better or things like that? When the field sort of started moving more towards the realm of computer scientists were much more comfortable with a little bit of a black box approach. So they were like, look, forget about causality. All we really care about is predictive power. And that has...
So one second, I
sure.
This thing, because, we want to make sure that the audience...
Sure, please.
Some of them
please.
are school children, this thing. So you're using a few words.
Sure.
I want you to expand on them in a very simple way. One is causality. and this
Okay.
predictive thing. So what could you define that in simpler way?
Yes, yes. So, uh, so let me give you an example of causal. So causality simply means that you're trying to say that there is a cause and effect relationship between two things. I gave you the example earlier of fertilizer. A simpler example is if I eat too much chocolate, my waist expands. So there is a cause and an effect. The cause is I'm eating too much chocolate. The effect is my pants have got tight for me. Now, if I were to talk about prediction, I don't care to understand. There, I might be more interested in just saying, when are my pants tight? I'm not really bothered about whether it's eating too much chocolate or whether it's because my pants shrunk because I washed them the wrong way or I bought the pants of the wrong size. They simply are tight for me. So that would be, in a sense, prediction. All I'm trying to understand is the outcome.
Irrespective of the cause.
Irrespective of the cause. So I don't really.
How do you predict outcomes without? You may have multiple causes, and you say give weightages to causes and say this is the outcome.
Yeah, it's almost saying, look, I don't care why your pants are tight. There are 800 different reasons that could have made your pants tight, but I know that if this combination of those 800 different reasons happen to be in play, then your pants are going to be tight. Otherwise, they are not going to be tight. So now let me give you, maybe a little bit more of a realistic example. So for example, say if you're going shopping, you go shopping on Amazon, you'll start seeing recommendations of things to buy. That's a pretty good example of prediction. There's something running in the background that says, don't ask me why I think Aziz is more likely to buy this stuff, but based on what Aziz has bought in the past and what things are on sale, blah, 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 I think, I predict Aziz is more likely to buy, say, T-shirts rather than formal shirts. And is it,
Yeah. And maybe which color and which way.
And which color.
Which brand and what price range and all of those things.
Correct. So where the field in a sense has gone is, if you think about what the field was like 20 years ago, and at least the part of the field I was in, we were trying to play God, where we tried to say, this is how the world works.
Who is this we? And
the we being the data science professionals, the statisticians, and the quantitative economists.
Okay.
We would act as though we actually understood how we would act as though the world is as simple as if you eat too much chocolate, your pants get tight.
Okay.
Now, that was fine when you had not much data and you were trying to understand why your pants, and maybe you didn't have much data, there's not much you could do. So you said, look, at least let me try to hang my hat on what I think are reasonable links between cause and effect. Now what's happened is that the number of variables, the number of factors we have that can influence a decision have become so big, and the scale at which these things run has become so massive that we've essentially given up on, for lots of things, we don't even care what is cause and what is effect. All we care to know is, at the end of the day, if have I got a good prediction? For example, in the the Amazon shopping case, all I care about is how good am I? How good is the algorithm at predicting what somebody is going to buy. It really doesn't care about why the person is making that. But now we have gone from coming up with 8 reasons why somebody buys something to maybe 80,000 reasons, 80,000 possible factors.
So coming back to what the audience might be interested in, and
sure,
today's session may be a little different from previous spheres of learning sessions, where I'd like a little more participation from the audience, and y'all are free to ask questions on chat. I may still moderate them, and we'll start with initially one question per person, and then if there are more questions, then we can take a second round and third round depending on how many questions there are. Right. So feel free to write on chat, and towards the end of our session, we'll also open it up for verbal questioning as well. Right. So, yeah. So, Aziz, coming back to, you started off as a mechanical engineer. When did you realize that you can, do all this? You wanted to go into this field, which wasn't even called that field yet. And what would you tell, I don't know, a student of 11th grade or 9th grade who's heard a lot of, these words, these buzzwords, and sometimes they're even college students, perhaps in the audience, who are then trying to figure out what career to choose, right? What would you tell them how they go about deciding whether this is something they should do or pursue, and what the scope of things that are out there?
Sure. So now this is my take, and I'm probably a little bit biased, but the way I see it is that being data literate, and by data literate, what I mean is the ability to understand essentially understand how to use numbers to make decisions. That is going to be almost like a 21st century prerequisite. And the reason I'm saying that is, even when I look at what's happened in my own experience with people I interact with, 20 years ago, senior management would tell me, what do you know? I've been doing this for 25 years. You need to know gut. It's all about gut and this and that. And now the same senior managers are all about, well, show me the numbers. So I would almost say that, having some degree of ability to understand numbers is going to be almost, I think, is increasingly becoming a prerequisite, almost independent of the field. Now, with that said, how do you go about doing this? So I would say, what I would say, think about the blocks. You need to make a decision. How do you make any decision? Whether it is, say, let's take an example. Okay, which batsman is going to score more in a particular cricket game? Now, you could make the decision based on lots of things. You could say, let's see how confident he is, or let me look at his videos, this, that, or the other. One alternative way to do that is to say, well, let's try to put some numbers on goodness and what we think are going to be factors that speak to how well a cricketer performs. So it could be, let's see how he's done in the past. Let's look at how he's done in the past under similar pitch conditions. Let's look at how he's done across similar similar teams, so on and so forth. So to me, the way I would really get started is to ask, how can I use any form of data to help me make a decision? So to me, really, that is the starting point. It's less about saying, I think the one advice that I would give, I give folks, which I feel quite comfortable giving, is that sometimes folks feel that they need to start by saying, I need to learn Python, or I need to learn how to make a neural network. And I say, no, that's a wrong place to start. The right place to start is to first understand how you're going to use data with any sort of what I would call a data analysis tool. And your data analysis tool might be as simple as saying, let me just make some very simple plots. So for example, in the cricketer example, it could be, do I think batsman A, this is a pretty good, let's say something like this, right? I'm trying to figure out who's going to have a higher run rate. Well, one way to think about this might be, what has been the run rate in the past? and then what has been the run rate in the past based on, say, some pitch conditions or who the other team is or things like that. Because then you start thinking about, okay, this is how I'm going to use data. And then you start understanding, oh, but now what do I do if there are too many factors? Then that naturally leads you to say, okay, if I'm trying to think about 8 different factors affecting run rate, then I need to have some systematic way to combine these 8 different factors. And then I would tell you, okay, now that you need to know what to do if you have 8 different factors, then you learn whatever is the technique.
So there was a question from Shreya. She said that if she's a computer science major, I'm paraphrasing, does it make sense to do courses in data science, or is that not using a computer science skills to the fore?
So I would say that's actually a killer combination, because what I've noticed in my own experience is that folks who come from sort of a pure statistics or economic, or like me, who are pure economists, at least when I started, I only had the skills to handle problems where the data sizes were manageable. Now, the way things have gone, data sizes are no longer manageable. So you almost need some amount of a computer science training to be able to do anything interesting. Now, folks who are pure computer scientists who have not taken any statistics training, they have the opposite problem. They know how to handle the data, but they don't really know what to do with it. So they would tend to make they might even make some pretty basic errors in how they would do their analysis.
So how to look at assumptions, hypothesis, all of that is one piece of it. If I'm just
absolutely
paraphrasing you, and the other is the tech skill itself to crunch data, and both are needed so that you can apply the technology skill of writing code, algorithmically efficient and optimized and all of that kind of stuff that is crunching to billions of lines of billions of bits of data, which is a computer science problem. But unless you know how to apply it, and that's where the data science as a field kind of merges the two, right?
Yes. So, for example, what I have spent probably the last couple of my years, in my career, the skills I have been trying to pick up, it's been almost basic computer science skills. So a couple of years ago, when I was running my own shop, Rational AI, I really realized that what I need to do is to write good code. So I really started getting serious about actually writing higher quality code. And I did it not because I wanted to become a computer scientist or a software engineer. It's because I almost needed it so that the analysis I did would run.
And over here, you would use languages like Python to write the code. Is that the language of the future? I've heard that, so I want you to comment on that.
Sure. So see, what's kind of interesting is that as I was telling you a little while earlier, statisticians sort of started the party, and then a whole bunch of computer scientists gate crashed on it. Or you could say fortunately they were, that the statisticians were smart enough to invite them, however you want to say it. So what's really neat now is that Python has almost become this, this very nice gateway to do all this analysis. So even if you are doing something that actually is running in C or machine, some more complicated language, what's nice is that anybody who's put together something really complicated, everybody realizes that, hey, in order for it to be used, nobody is going to use it if it's in pure C or some other such language. So they all provide you an interface, and that interface is typically written in Python. So it's almost like Python has become like a universal language for data science, somebody might have written code in Fortran, somebody else has written it in C, somebody else has written it in God knows Pascal or whatever. But they all basically have said, look, forget about what language the stuff we have done is written in. What we'll do is we'll give you a way to interact with us in Python. And so
and then you can visualize the data and
you can visualize the data, you can analyze the data, you can do lots of things with the data. But
and Python allows you to do all of that?
Yes. So Python is definitely so to give you my own journey, when I started picking up a language, I've gone through everything from Fortran to C to MATLAB to a bunch of others. And the most recent transition I made was from a language called R to Python. Mm-hmm. And what I have found that as a practical matter, Python is definitely a majority language in the sense most places, I'd say 80% of the data science teams I know, they use Python as their main language. And it's not that Python is inherently superior or something. It's just that, like I was telling you, most of these packages are all written in something else, but people have bothered to provide you a way to access them using Python. Okay. So once you know Python, you basically have a way to go to access all these other packages.
A few other questions. I've completed my master's in maths. I don't have any CS skills. Is data science a career for me? A similar question. I wanted to be a robotic engineer. I'm doing a data science course right now. Is it right? These are two questions.
So let me take the first one. See, I really have an interesting path to here. So when I was an undergrad, I felt, like programming is for wimps. Like real engineers don't write code. Like, they build stuff. I mean, they kept their hands dirty.
I remember your idealism in those days.
Yes. So at some point, I realized that, man, you try to do things in the physical world, you can't really scale. In the sense, you're tinkering around with one engine or whatever. You can only do that one engine. But if you can take things into the virtual world, meaning you start coding, you get phenomenal scale. Once you figured out the problem in one place, you can use the same thing in 1,000 other places. So, I essentially am a self-taught, at least from the computer science part, I would say I'm really self-taught. The only computer science course I really took was Fortran 101 in 1984. I haven't taken any computer science courses after that.
But you still taught finance and statistics and all that, CMO and all that. So you have the finance and stats background, and then you took the computer science skills too.
Yes. So this is something that's, very, at least the part you need to do data science is very learnable by yourself. Now,
what is the difference? One question was there. Sorry.
Sure.
Is there a difference between data analytics and data science?
See, everybody sort of throws these labels around very freely. I would just tell you that data science, in a sense, is it's a continuum. Somebody will call making a graph data science. Others will say, no, that's not data science, that's visualization. I would really encourage you not to get hung up on what is, pure data science or not. To me, the real question is to go back to why are you doing data science? You're not doing data science because you want to you want to make a nice looking graph. You're doing data science because you want to get a better answer to your question. So
that can be done whether you're a farmer trying to figure out what's the best amount to spend on fertilizer to get the best yield. So there's a cost. There's both a cost and a productivity factor that you weigh. Right. Or it's weatherman, or it's manufacturing, or it's reliability of computers, or giving loans to people.
Yes.
Almost any industry can kind of use data science.
Yes. So even people somehow feel that, if you don't know Python, you're not a real data scientist, whatever that means. I would tell you, the only qualification you need to be a real data scientist is that you use data to make decisions and you know what you're doing. You understand what are the limitations of your analysis. You realize you understand if you're saying something, saying the data supports me, you understand whether the data is actually supporting you, or are you overreaching on what the data does or does not say. So to me, that's really the way to think about it. And when you think about it like that, you could be doing data science in Excel quite easily. Excel already has built-in things like if you want to figure out what's the, say the averages of two different groups. Say you're trying to figure out, let's go back to the cricket example. People who have, cricketers who have scored better in the past, are they more likely to score better in the future? That's saying, okay, let's look at past performance and see how it correlates to future performance.
And there is that Netflix movie that some may have seen called Moneyball, where there's a guy who's just selecting the team, and he just based on averages, they outperform every other team just with data science.
Correct. So you could be doing it as in something as basic as Excel. Now that itself is a good way to enter this, because you can start getting up to speed pretty quickly. And then once you say, oh, this is cool, but you start running into the limitations of Excel, then move to a programming language like Python.
So there was a couple of questions also.
Sure.
How important is Java as a primary language, or is it better to do Python to start with? Question from Harman.
So I would say, at least if you want to do any sort of data analysis, you want to be able to visualize your data. That is, you want to see the results of your analysis. It's Python, like 90.
Python's
by a very wide margin. I don't use Java, and nor do I know anybody who uses Java to do data analysis or data science.
And also, can data science be used in astronomy or space?
Absolutely. I'm almost certain it's already used. So let me give you an example, right? One of the relatively, famous problems at least in rockets is trying to figure out where the rocket is going to be in the future, given where it is now. And a guy called Kalman, Kalman, he figured this out years ago, and it's basically data science. So this is very much used. Now, again, just go back to what you're trying to do. If you're trying to solve a problem in astronomy or in something about space travel, ask yourself, what's the question you want to solve? If it's, say, astronomy, you're trying to figure out something as simple as what's the likelihood that I will be able to see Jupiter on a given night? How do you make that decision, right? You could say, well, I'm just going to talk to my friends, or you could say, well, let's think about when do I see Jupiter? Say, like, what's the temperature, what's the pollution, things like that. And then you start saying, okay, when I look at something that's, I look at a bunch of observable facts, I can then find a pattern as to what combinations of these observable facts are linked to when I see Jupiter.
Another question from Aiden. I'm interested in sports data. How can I start visualizing it by myself?
Well, I would tell you that, if you're, so Aiden, I think you're doing it the right way, in the sense you're taking a problem you're interested in, and you're asking yourself, what's interesting about, what can I learn from the data that's interesting about a problem I care about? Now, I would tell you, start with a tool that allows you to get into the problem you want as quickly as possible. So if you don't know Python, don't sweat it. Use Excel, use whatever you want. Excel has some basic visualizations right there, and they might be enough to get you started. So even, say, folks like me who've been doing this for a long time, we still use Excel to do some quick and dirty analysis. So there's absolutely no shame in using whatever is the the simple basic tool you know how to use to get your stuff up and running. And then once you started using it, you'll start saying, okay, Excel has this limitation and that limitation. And then you say, okay, if I want to overcome these limitations, I need a more sophisticated tool. Odds are pretty good you'll move to Python. But that's a logical way to do it. You don't learn Python just because somebody says, oh, Python is cool. You'll say, I'm going to learn Python and I'm going to learn how to visualize in Python because this is what I want to be able to do. So then you have some focus on where you want to go.
In fact, kind of associated with that point and some of the previous questions, people who want to look at whether they want to even look at data science as a career, MySphere has put together a lot of curated resources across different career paths. Data science is just one of them, right? And so, for example, this page, there are a lot of introductory resources. There's free video courses, there's online courses, there's on-campus courses if you're thinking of doing, a physical course somewhere. Maybe some of them may offer even hybrid or virtual courses. What are books that one can start reading on big data and their data science, and some YouTube channels and other notable personalities. Aziz, we look forward to having you listed here at some point.
Sure. I don't think I'm in the same league as Patil, but I'm definitely not in the same league as Hinton. I don't think I ever will be. But,
So, and then of course, events and competitions and magazines and associations and even internships and even movies. So I referred to Moneyball earlier, right? So that is a great movie. If you really want to fictionalize, and this is not fiction, this is actually a real story. It's made into a movie, right? On how a baseball manager basically converted a team that was always losing on a losing streak. And over a couple of years, he started having just winning streaks, even without, within a very small budget. So he had one of the lowest budgets in the league, and they still were able to outperform just using data science, right? So even to spark interest on whether it's something you want to do, movies like this could be useful. We've collated things like this, not only for thing on data science, and this is what it could be for across different careers, by the way. So Spheres of Learning is MySphere is a platform where you all can explore different careers, data science just being one of them, where it might be, content writing, maybe architecture, maybe biomedical, mechanical engineering, social entrepreneurship, any of that stuff, right? And so I'll come back to some of this. And we look forward to, over time, even having internships on the platform, right? So we'll be reaching out to different corporates to have internships listed here, and some of you all can apply to internships. And again, the internships might be across different skill sets that may be needed. Some of which might be hopefully be from the data science arena as well. Okay, coming back to the next question. Why do you talked a lot about Python, but why do people use Python for data science? Is it because of the simple syntax or other features?
Oh, see, I think this is my take on why people are using Python. So, part of this is just a network effect, meaning Python started being, at one point, it had a bunch of things people liked. So people started using it. Then once people started using it, then more people started using it. And then people said, oh, if I'm going to develop something, probably I should do it in Python. So it started to grow and grow in popularity over time. Now, roughly speaking, the way the two languages that are used a lot is something called R and something called Python. So sort of traditionally what has happened is that R was developed by statisticians. So R is very good if you want to, you want to do some very complicated statistical method. Or statisticians like R because that's sort of what they were using historically. So they tend to say, okay, if I want to get publicity for the method I've used, I'm going to try to get the statistics community to actually use it by putting it into R. Now, Python, in a sense, started with computer scientists were the ones who sort of were initially using Python. So for example, initially, if you want to do something like this the neural networks and stuff like that, it was built in a lot more into Python. So if somebody wanted now to, they came up with their own neural network, they said, oh, I want to get other people to use it, they would put it into Python. So these two languages initially started evolving. Then over time, I don't know why it happened, but one of my guesses is that data sets got bigger and bigger. Computer architecture got more and more complicated. So you almost needed some amount of computer science and software engineering to really do your work well. And since the computer scientists sort of had that, they were able to do things like saying, okay, now we'll provide you easy ways to handle billion data sets with billions of observations. And since over time, kind of the data sets generally grew bigger and bigger, people started migrating a little bit more to Python. And then once it got past a critical mass, everyone sort of converged, everyone sort of gathered onto Python. So I think that's sort of why Python picked up.
Here's another thing related to careers. Is the international job market, does it look for undergrads with courses in data science and finance?
I would say the international job market is looking, is not hung up on a particular particular field of expertise, because
so there's no prerequisite if you go the same. Yeah.
No. So for example, I'll give you a live example. We recently hired somebody whose previous job was using data science to make a winery a winery run better. But now we're going to tell them, okay, whatever you learned with respect to growing grapes in order to make fancier wine, you can use those same techniques to help us figure out some things in finance. This is not at my company, it's at another company.
Is there any academic background as a prerequisite to do data science?
See, what helps is if you have a quantitative background. So for example, if you the ideal background is if you have something like computer science and statistics, then you're really set. But even if you don't, people come to this field from lots of different areas. For example, if I were to hire somebody, I personally like to hire people who have some amount of a social science background. So they've done economics or even sociology or things like that, because they tend to be very good at thinking about, oh, let's think about why this is happening. So they go a little bit into understanding a little bit about cause and effect, which
but
is useful.
Even if they don't have a math background, it would work?
Yeah, totally. Actually, the amount of math you need to do this stuff isn't that high. It's
not all those complicated equations and all that stuff. Huh?
No, in fact, it's
because most of us normal mortals, we say, oh no, that's not for us,
Yeah, so I remember when I also learned statistics. I think those books are written by sadists because they just want to torture you for no good reason. I mean, what you really need to understand is kind of pretty simple. So it's almost like, don't get hung up. I mean, if you don't understand how to do this stuff in matrix inversion or whatever, I mean, chill, it's not even relevant. What you have to understand is, hey, this is how the method works. This is what it's trying to do. This is when it's going to break down. Stuff like that. It's almost like you need common sense, and you need to be able to apply that common sense with numbers. It's not that high of a bar. So
okay,
I would say,
that's good to know for many people who may not want to take advanced maths in college.
Yeah,
you're saying that you can be a data scientist
completely,
and they may not be a computer science nerd either, but if they
Yeah.
have a good common sense knowledge, they could get into this thing. But at the same time, if they are very good in math and computer science, that also works.
Yes. See, it's like anything else, right? Uh, what I would tell you to do is figure out where you can find a way to leverage your interests and your expertise. So, for example, if you already are interested, say, in sports or something, figure out how you can use some amount of data science and then actually uh, come up with, do something at least interesting initially in sports, because then you'll realize, for one, you'll have some intuition to guide you at least initially, and you'll be able to say, okay, I'm using this technique, but it doesn't make sense to me because I know this just doesn't make sense. So that will actually help you to understand the techniques you use in data science better. And then once you've got a good foundation, then you'll find it much easier to say, okay, now I'm going to use those same foundations in actually something maybe a bit different, like advertising or whatever. If that's helpful.
Okay. I wanted to show the group a little bit about the platform that I was showing. So besides stuff, because some of y'all are still trying to figure out whether y'all want to use data science, do data science as a career. We'll be exposing y'all to many other careers as well, right? And one thing that a MySphere can do is, you can create your own profile on MySphere, right? And it's kind of like, you can write about your education, your work experience, your coursework, projects that you're doing. So you start creating a portfolio, right? Any accomplishments that you've done, maybe sports accomplishments, hobbies, other memberships of things, skills. So then when you're applying for an internship, whether it's in college or you're graduating from college or going from high school to college, it becomes like a timeline CV. So you can do these projects, and the platform also has the ability to write your own blog, right? So you can start writing and discovering where, a lot of times by reflecting and writing, you discover your own interests, right? Because sometimes you can attend many talks like this, and then you kind of say, well, I forgot what Aziz said. But guess what? If you actually attend a talk and then you spend some time and saying, try and write one paragraph of what you thought you learned from the talk, you'll suddenly realize, hey, it is something maybe I have an interest in, and something that maybe it's not for me, right? So MySphere is a platform where you all can start writing your own blogs that's available to everybody, writing your own diary, accumulating your projects, making a CV, all of those things. And there's a lot of rich information across different careers, including, so for example, you want to do a science writer, scientific writing, or public health, data analytics. There was a question earlier on data analytics. So there's another talk that we've had with somebody else who's been a business analyst. Maybe you don't want to be like Aziz, who's so we would be interviewing people at different levels of their careers, right? And showcase there, so it'll help you make your decisions, right? Anyway, so now what I'd like to do, Aziz, is if you're okay with that, is open it up to verbal questions from the audience.
Sure.
So I'm not the moderator unless somebody becomes disruptive. Yeah. So can I ask my co-host to allow people to unmute themselves? Maybe raise your hand first, and we'll call you out, and then you can ask your question if you have any.
Yeah, participants can raise their virtual hands. Then I will unmute them.
Okay. Thanks. If you still prefer to just give written chat questions, that's also fine. There is one that came in. What is the relationship between machine learning models and data science? And are CS and math degrees needed for data science jobs in Mang companies?
Sorry, in what companies?
I guess Mang is what Microsoft, Amazon, Apple, and Google and stuff. Yeah.
So see, it's what I was telling you earlier. machine learning is, people like to make this distinction between statistics and machine learning. It's really it's more like one big continuum. In fact, the most famous book on machine learning is called An Introduction to Statistical Learning. So this distinction is somewhat of, it's somewhat of a fake, false distinction, and some of it is just hype. But so with that being said, the part that is a little bit real is that distinction is that machine learning tends to be, as I was saying earlier, it's more about saying, how do I come up with a good prediction? I don't really care about understanding cause and effect. And machine learning is really, it's saying, I really don't care about, I'm perfectly happy with a black box, but I want this black box to make really good predictions. And in that sense, machine learning has, it's really evolved to say, let's try to figure out all sorts of clever ways to squeeze some signals out of data, particularly when you have thousands of very weak indications of what's going to happen. So like I was telling you earlier, you're trying to predict what somebody wants to buy on Amazon. You might use, and I'm just making these numbers up, but you might use as many as 80,000 inputs or 100,000 inputs. And that's not typically what you would use a more traditional, at least a more traditional statistical method. And by the same token, when you use these methods, you really don't have a good handle on which of these 80,000 is causing you to buy or not buy something. And in a sense, you really don't care, because all you care about is in a sense getting it right.
And would you say then that there's a very large intersection between data science, machine learning, AI, and all of these all kind of feed into each other, have very large overlaps?
Yes. In fact, at least the way I think about this is that data science is everything. If you're going to use data to make decisions, that's data science. And then, different people think about it differently. What is AI and what is machine learning? Some of that is just whatever you want to call it. Now, a neural network, some people will say that's AI. Some people will say, well, that's actually just a branch of machine learning. So AI is a subset of machine learning. So I wouldn't really get hung up too much on the labels. I would really get hung up on trying to ask the question, what is it I'm trying to do? And if that's what I'm trying to do, what is the appropriate technique to use?
Okay. If someone wants to pursue data science, should one take admission in engineering or computer school? Can you guide the path for the same? I can also comment on this, Aziz, but
please. Yeah, go ahead and then I'll add to it.
Okay. So, see, typically on this question, if you're looking to go abroad or, maybe even in India, it all depends on the school. So some schools might have data science as an interdisciplinary discipline. Some may have it within the computer science program. A lot of times, one can actually chart one's own course, talking to the counselor of, one or more departments. So it all really would depend on the school itself. And sometimes schools give the flexibility to even define this, not only at the time of admission, but within a four-year program within the first 2 years. So again, I would kind of concur with Aziz, is don't get hung up on the terminology of, sometimes there's even data science is there, then cognitive science is there, which might have a little bit more on the social science side, but it also has the other elements, and it in many different schools may be offered by different programs. You can add, Aziz.
Yeah, so I would even make it broader than that. You don't even have to think, should I do engineering or computer science? I'm trained as an economist, and the types of data scientists that at least a lot of the tech companies have really tried to hire of late have actually been quantitative economists. And the reason they liked what economists bring to the table is because these tech companies, they actually really want to get a little bit better of a handle between cause and effect. And economists have been fixating on understanding cause and effect for the longest time. So they, even if you take a black box model to them, they'll really try to tweak it to get some idea of cause and effect. And the reason they care about that is, let's say, I'm just making the stuff. If you're Facebook, you're trying to get better, say better. Helpful to understand a little bit about what makes user engagement better. Is it, is it the color of the screen? Is it the font size? Is it the topic being discussed? What is it? Just to put some numbers here, I think as of now, Amazon is probably the largest employer has the largest economics department in the world.
Really?
Yeah, or at least one of the largest, if not the largest.
And why is that? Because of optimizing things? Or?
Yeah, because they want folks who can, who think a little bit in terms of business, and at least economists, they have some idea that there is this notion of money. Money is something that should be maximized at some level. So if you're a for-profit company, you kind of like that mindset, and then they have this idea of putting some structure on the problem. And so now if you have those two things and you have some amount of computer science training and some amount of statistics training, you become a pretty attractive package of somebody who can solve problems for a highly technical company.
So, for example, you said that you're working at Two Sigma in financial services. So could you give the audience just a general idea, without anything confidential, of course, on what is the kind of problems that you look at? What is the broad nature of things?
Sure.
What do people who work on Wall Street work at?
Sure. So let me, instead of going into the specifics of Two Sigma, let me give you a sense of what people on Wall Street might do. So for example, if you are at a quantitative investment firm generally, one of the big things you're always trying to do is try to essentially predict stock price movements. So there one might try to say, okay, let me try to predict stock price movements in terms of, say, is the company going to beat revenue projections? And this, what's a pretty famous example out there is that people said, okay, let's actually get satellite images to see how full are parking lots. Because the idea is that if you see a parking lot that's empty, that means people aren't going to the store. That means revenues are going to be lower. So the company is probably going to miss its revenue projections. So that's one example of the kinds of things people do. Another is, they might, let me give you an example from another world, which is politics. People are trying to figure out, is a candidate's message resonating? So they may do things like look at something as simple as foot traffic to an event, because when your mobile phone,
or retweets on Twitter,
or all of that stuff.
Okay.
And this is real. People are actually using it. When amongst the things I did is I also used data science for politics. I was a data scientist supporting a presidential campaign.
Really? Okay.
Yeah. So people are trying to, you're trying to figure out, okay, what sort of a message do you send to someone so that they're more likely to vote for you? So, if you're an 18-year-old, you'd say, vote for me because whatever, I'll give you free schooling. If you're a 60-year-old, they'll say, vote for me because I'll make sure you get your social security, things like that.
Interesting.
So data science, really, it's got a very broad usage. And the reason it's pretty broad is, what are you trying to do? You're trying to make a better decision using numbers. I mean, you got to make a decision pretty much in any field.
Right. So I'd like to now ask all participants to share your feedback on the talk. My colleague has shared a link in chat to everyone. And we really learn a lot from feedback we receive from participants. So we really request you to spend, it'll take you less than 2 minutes to fill out the form. And because it'll help us choose different topics for the future, right? And so your feedback are really appreciated. And also to give feedback, it helps give feedback to the speaker, moderators, who we invite, whether the level that we are discussing in these talks is the right level for y'all, or would you all like to have other things covered, right? And so both Aziz and I would love to have feedback from y'all on this. Yeah, so any closing comments for a young audience, Aziz?
Yeah, so what I would tell you is this, that look at the companies that have had phenomenal returns in the last maybe 10 to 20 years.
Okay.
It's Facebook, it's Google, it's Amazon, it's Lyft, Uber, things like that. They're, what does Google do? All it really does is it processes information. What does Amazon do? Yeah, you go there to buy and sell stuff, but what they're really doing is they're doing a really clever job of joining two people, the buyer and the seller. And the way they are joining these people is really using data science, because they figured out, they made it very, very efficient to connect a buyer and a seller by using things like saying, who's going to, for which buyer and which seller is this the sweet spot to get this deal done. So my take on this is that when you look at companies of the future, a lot of them are about getting better at processing information to make some decision. So at least I'm personally quite bullish on data science as a career. And the reason I'm bullish is kind of threefold. One is the amount of data that's out there has really exploded. So in the past, even if you wanted to make a database decision, you didn't have the data. That problem is kind of gone away. The other is, and I'll give you real numbers. When I got into data science on Wall Street, this was in 2010. If you wanted to even buy a package that could do the kind of analysis you want, your license could easily go into 20, 30 grand. Mm-hmm. Now, Python essentially does what, 10 times what those $30,000 licenses could do. I mean, if you had to buy a license for Python today, it would probably be like a $100,000 license, and it's for free. So it's phenomenal. You get incredible access to algorithms for free. And the third is you've got a lot of data and you've got good algorithms, but now how do you process it? And processing costs, as you know, have just kept going down to the point now that if you wanted to run something, you could do it for equivalent of a few hundred rupees. So when you have these three forces that are aligning to favor using data to make decisions, it's going to be more and more likely that decisions will increasingly be made using data rather than the old ways of doing it. So at least I'm personally quite bullish on the field.
Thank you, Aziz. And with that, on that note, I'd like to thank you again for
most welcome
for coming on this platform.
It was a pleasure.
Yeah.
As always, Girish, thanks again for hosting me. Always lovely to have an exchange with you.
Yeah.
And thank you all for your questions and your interest.
Yeah. So thank you again, and all participants. And please fill out the form if you haven't done so already. Otherwise, the session is now closed. Yeah. Thank you. Thank you all.
Thank you. Bye-bye.
Bye. Bye. Bye.